Hello, my fellow developers. Let's say you need to calculate the total number of rows in a relational table. Yes, today we are talking about relational databases. And the first approach that comes to mind is to use the count star function. But if you Google, you will find many internet resources suggesting to use count1. Why? Because if you take a look at count star, you might think that star will return all the columns of a row, making this approach less efficient than count1. Alright, so should we use count star, should we use count1, or should we use count ID, where ID can be any column of your table? So let's explore. And today we are going to look at the 4 most popular databases according to the DB engines. We'll start with Oracle, we'll use MySQL, we use Postgres, we use SQL Server. We'll see either any difference for using count star or count1 in those databases. Why don't we start with Postgres? So every database has the following table created: table sample with 2 columns, ID of the integer type and val of the text type or varchar type. Let's see how many values do we have in this table. Let's run select count star. That's their default approach that comes to mind from sample. And you'll see that we have 1 million records in this table. What happens if you do count1? You have the same result. If you do count ID, you have the same result. So generally, whether you use star1 or ID, you are getting the same result back. But which one is a better option? For that, we need to look at the execution plan generated by the database. Let's start with the count star, and we need to use explain analyze. Explain analyze executes the query and displays the execution plan. So here is we need to read this execution plan from the bottom up. You can see that was the sequential scan. If you did not know that the relational database such as Postgres needs to traverse the entire data set. Yes, those are transactional databases. And as transactional databases, they don't keep any internal counter that is incremented or decremented whenever you add rows or delete rows from the table. Actually, every transactional database, Postgres, Oracle, SQL Server, or MySQL, they need to traverse the entire data set to return you the actual number of rows at the given moment in time. So what's happening here? You can see that to calculate the total number of rows, Postgres had to iterate through the entire table, sample table. But here is, pay attention to this width column. Returns the size in bytes of every row that was processed. And here is we have what? We have ID column and we have value column. And if you calculate their size in bytes, it definitely will be bigger than 0, which means that when you were using the count star function for the calculation, the database did not actually touch any of those columns. Let's compare this execution plan to the execution plan of the count1. Executing for the count1, and you can see the identical execution plan. We are iterating, we are doing the same sequential scan, and the total size of the rows is set to 0 bytes, which means that we just did the calculation. Do we have any differences if we do the calculation using the ID? Executing it. Yep, and here as you can see that the width column of the execution plan changed to 4. And 4 is the size of ID, is integer, it's 4 bytes. That's why you have 4 here, which means that it's less efficient. Not only the database needs to iterate through the entire sample table, but also it needs to retrieve the value of every ID column and see whether it's null or not, because this is how the count function works. It will increment the counter only if the provided column is not null. And that's why we need to check the actual value of the ID column for every row. But we don't need to do this for the count star or for count1, if you remember. What should we use? Should we use count star or count1 if we need to calculate the total number of rows in a table? So from the execution plan perspective, it looks approximately the same. But let's see the actual latency. Let's remove the explain analyze from here and execute this query a couple of times, and then we will execute count1 a couple of times and go to the output. So here is, you can see in the output we were executing count star, and for the count star the execution time was around, it was around 44 milliseconds or 48 milliseconds. For the count1 the execution time was around 55-59 milliseconds on average. And what's interesting about Postgres, in Postgres source code, there is a code snippet that checks whether an argument is null or not. And this code is checked even against constants, literals like 1. So that's why if you're working with Postgres, always use count star, because for count 1, there is an extra check. So count star is the winner for Postgres. It's faster and it generates the efficient execution plan that doesn't actually take and check any columns of your rows. Now, why don't we go to Oracle? Oracle has the same sample table. It has the ID of number time and the value of varchar type. And for Oracle, we need to run this request. Let's double check how many rows we have. We should have the same number of rows. Simple. Yep, we have 1 million rows. And now let's do this explain plan 4. You execute this query, explain plan 4, but then in Oracle you also need to select this latest execution plan from the DBMS explain view table. All right, let's take a look at it. And so here is the execution plan in Oracle for the count star function. No differences. You can see similarly as in Postgres, in Oracle, that's also a full table scan. Okay, that's a transactional relational database. No any internal counters in Oracle. Let's see this execution plan for count 1. Any differences? First, we are executing this count 1, and then we are doing select from the DMS table. Yeah, the execution plan is identical. So from the execution plan perspective, whether you are running count star or count 1, you're getting the same execution plan. What happens if you change to the count ID? Let's run for the count ID. For the count ID, you're also doing the full scan, but here is you've got this extra column called bytes. While Oracle were iterating this table, it was also checking the value of every ID column. This is how many bytes the database read during that iteration, which means that it's not free. And logically, even from the execution plan, you can see that count ID is less efficient than count star or count 1, which means that count star, count 1 also became our candidates. But which one to use? Let's take a look at the latency for these two requests. Let's do the count star first. Let's execute it a couple of times, and then we will execute count 1 several times. We go to the output screen, and here is, let's start with count star. You can see that average execution time is around 64 milliseconds, 60 milliseconds. If you do count 1, all right, the latency is actually comparable, 50, 60, 65. So the question is whether you use count star or count 1 in Oracle, it's all the same, no any differences. But if you want to have some generic approach that will work across Postgres and Oracle, then it's better to use count star. And by the way, I forgot to mention that count star was eventually added to the SQL standard. And it's set in the standard, when you're doing the count star, the database engine need to calculate the total number of rows. Okay, so moving forward, how about going to MySQL? So what do we have in MySQL? In MySQL, we also have the same columns, ID and value. And now let's run our request. Let's see how many rows we have. We should have 1 million from sample. All right, we have 1 million rows. And we do this explain command, we will see the execution plan in MySQL. So from the execution plan, you can see that here, that's a simple select, the name of the table, we don't use any indexes, average number of rows, etc. Generally, that's what you have. If you do count 1, let's do count 1, you're getting identical execution plan. So no differences from the execution plan. And also if you do count ID, all right, and for count ID, the execution plan is the same. The execution plan doesn't say anything, which means that we can compare the latency. So let's start with the count ID. Let's execute this count ID several times. And even right now, you can see that it takes several seconds. Let me execute it here 3 times. Then I'm doing this count star. Count star was instantaneous, just a few times. And count 1, it's also quick. Going back to the output, let's scroll up, let's find the count ID. You can see that for the count ID, Okay, it took us 2 seconds and 700 milliseconds to complete this query, because effectively it means that not only the database was iterating through the records, it was also checking the ID value of every row for the null, like whether it's null or not. If it's not null, then the counter is incremented. If the ID is null, then it's skipped, it's not incremented. So it's like more than 2 seconds, almost 3 seconds for the count ID. If you compare this to count star, then it took around, let's say, 220, 230 milliseconds. It's good enough. And for count 1, it's also 220, 25, 210. So generally it's comparable. And all it means that if you want to calculate the total number of rows in MySQL, it's so comparable to Oracle or Postgres. You can use count star, just use count star. If you prefer count 1, all right, that's count 1, not a big deal. But count star works as well. The same execution plan and the comparable results. And lastly, let's go to SQL Server. We have the same sample table, the same columns, ID and value. And all we need to do is to run a few requests, right? So for a SQL Server, I want to enable this property statistics profile on, and the next query that I'm going to execute will be executed, and we will collect all the details, and those details will be displayed. So let's do select count star. That's the query that we want to run. And here is what we have. Yeah, that's also full table scan. No surprises. That's a transactional relational database. You are doing the full table scan. That's what we are doing, table scan. Then the next item, you are going to do this count star operator for all of the rows that you iterated. The execution plan in SQL Server comes with a lot of details. All right, so let's compare this execution plan to count 1. Yeah. So we're also doing the full table scan. Yeah, the object, it's our table. And actually here is, take a look at this. Actually, when you will be iterating through these rows, then SQL Server will execute count star. So effectively, even if you use count 1 in SQL Server, internally the database will be executing the count star function. And that's actually makes total sense, because count star is also defined in the SQL standard. Okay, so how does it compare to count ID? For the count ID, we also do the full table scan, but then we have this defined values. You see, this defined values column is no longer null in this execution plan, which means that while the SQL Server will be traversing this 1 million rows, it also will be picking and checking the value for the ID column. And then that ID column will be passed to this expression count ID expression, and that will take more time. So like from the execution plan, it's obvious that count ID is also slower than count star count 1 in SQL Server. So how about checking the actual latency? Let's turn off the profile statistics. What if we do count star? But like, we know that it's probably also a silly exercise, because you saw that for the count 1, SQL Server actually executes count star. But nevertheless, we did this for other databases. Let's do it here. Count star here, around 100 milliseconds. And here it's also comparable, 199 milliseconds. It's all the same. And before we finish, let's talk about indexes. What if I have an index on the ID column? Will the things be faster? So let's check it out. So let's check this, but only for Postgres. I don't want to check this for other databases, because the results will be comparable. Let's go to Postgres. Let's create index, primary key index on sample table for the ID column. Okay. Done. And also, just in case in Postgres we want to run vacuum analyze, that will analyze statistics. And now, if you do this count ID, let's do count ID, and let's do explain analyze. So you can see that Postgres still does the full execution plan, even though the index here, Postgres understands that no, like I need to calculate the total number of rows, which means that whether I'm iterating through the table or whether I'm iterating through the index, there is no any difference. That's why Postgres ignores the index. But the index will be useful if, let's say, you have some filtering value, like from where ID is bigger than 900,000. In this case, that the database engine is smart enough, and in this case, certainly it makes sense to use the index, and the Postgres does the index on the scan. So if your task is to calculate the total number of rows in a relational database, and if you think that the index will expedite this process, it will not, because for the total number of rows calculation, the database still needs to traverse the entire table. But if you have some condition, like where ID is bigger than something, then in this case, the index will make total sense. It will make this count function running much faster. All right, so enjoy and see you soon.